Okay, so let's look at this question. So before we evaluate this integral, we will talk about a delta function. So the delta function is a ideal imaginary function. So it's called an impulse function. So the symbols look like this. It's arrow. Okay, it's not a little bar, it's arrow. It has the following property. First, the area equal to 1. Okay, and the base of this, you can imagine that rectangular is approach. I will say is approach to 0. So to keep the area as 1, if you can imagine, this is a tiny rectangular shape. The area is 1. So if the base is very, very small, so the height is gonna approach to infinite. So if you integrate, so how to gather the area of this one? So if you integrate this delta function, delta t, this delta function dt, then you will find the area equal to 1. Okay, that's the first thing you need to know about delta function. What about if an arbitrary function multiply with a delta function? Say we have a arbitrary function xt, and if you multiply with a delta function, okay, so the result is still a delta function, but with a coefficient. We'll time here the value of this function. Here you plug in the location of your delta function. For this one is 0. Okay, multiply with x0. So this is a constant. This is the function. Okay, so if you integrate this function, arbitrary multiply with delta, integrate this function, it equals to x0 dt, delta t dt, and this is a number, so you can take it out. Then it becomes integration of a delta function. You know it's 1, so it's just that. So if you integrate that, you got a number. All right? What about this? What about an arbitrary function multiply with a delta t minus 2, for example? So delta t minus 2 is the delta function moved to the right for 2 units. Right? Minus 2 is moved to right for 2 units. So that arbitrary function xt, so if you got this one, gonna equals to delta t minus 2 is still this function. We move a little bit. Multiply with a x2, which is a location of this delta function, which is 2. Okay, so again, this is a number, this is a function. If you integrate that again, you will just need equals to the number, because this delta function integration equal to 1. That's the area of that one. All right, hope we are clear about the delta function properties. So let's start to look at this question. Okay, let's look at this question. So part A, I equals to an integration of -1 to +3. Let's extend this brackets, so it becomes t squared cubic plus 2 multiply with a delta t and plus the same function multiply with a 8 delta t minus 1, okay, and dt. Okay, we actually can, make it separated into 2 integration. Okay, we're gonna do that later. So for this one, this is xt multiplied with delta t. Okay, we just plug t equal to 0 into this one, right? Because that's the location for the delta t. We learned this. So this one becomes -1 to 3, and we plug this one into that. That's 2 delta t dt plus another one, -1, +3. And in this one, the location for this one is actually at 1. Okay, this is 0 because it's delta t moved to the right for 1 unit. So we plug a 1 into it. That is 1 plus 2. That is a 3 multiplied with 8 delta t minus 1 dt. Okay, then let's evaluate these two. So the location here is 0, so within that range. So we know this one becomes 1, so it's 2 times 1 plus a 3. That's 24 times another 1. So this is located at a 1, so it's still in this range. So this is 1. So we got this one equal to 26. Okay, so that's the first one. And let's look at the second question. For the second question, again, we're going to evaluate this one by one. So part B equals to integration of -2 +2 t square delta t dt plus -2 to +2 t square delta t plus 1.5. Okay, this is a plus this time, and the next one is dt. So we can make it into 3 individual integration, and the last one is -2 +2. Let me bring it a little bit smaller. Then t square, what is that? Delta multiplied with delta t minus 3 dt. Okay, so in this case, we got the location for this one is t equal to 0. We're going to plug it in. So t equal to 0, the whole thing is gone. So the first term is just 0. Okay, and the second term here, we got a t actually equals to -1.5. All right, so that's a 0. So -1.5. That's the delta function location. You plug this in. So it's -1.5 squared. Okay, so that's the coefficient at the front. Without that, you know, this one is just 1. Okay, because it's actually within the units, the range. This one interesting. Okay, this one pretty interesting. So t gonna equals to +3. Okay, this is 0, and that's the 3, that's the 1. But you know, we supposed to put this one in. Okay, we can put it in. So the function inside of this integration becomes 3 cubic delta t minus 3. That's not a problem. But the problem is we are evaluating between -2 to +2. Okay, which is not including this one. So when you integrate this one, this gives you a 0 because it's not in the range. Okay, so the whole thing is 0. So in the end, we just have 1.5 squared is 2.25. Oh, good.